Hello everyone, welcome to another class of ECE104a General Engineering Enhancement Course 1. So today we're going to talk about probability and statistics. So our course content for today, combinatorics, which includes fundamental principle of counting, permutation, combination, Venn diagram. Then for probability, we'll have basic probability, probability operations, probability distribution, conditional probability, and expected value. For the statistics, so we'll have measures of central tendency, measures of dispersion, measures of position. Now let's start with combinatorics. Ayan. So this principle states that if there are ways to do one thing and S ways to do one another and T ways to do a third thing and so on, then the number of ways of doing all those things at once is R times S times T, and that is what we called as the fundamental principle of counting. Okay, so let's apply this principle in this problem. Combo meals come in 3 dishes. One can have pizza, spaghetti, and a burger. If there are 4 types of pizza, 3 types of spaghetti, and 2 types of burger, how many combo meals are there? So, applying fundamental principles of counting, so let's just compute this as 4 times 3 times 2. And of course, our answer would be 24. So that's the number of combo meals that we can get. Okay, so next problem, A, B, C, and D are going to ride in A's car to go to the mall, but only A and C know how to drive, and D does not want to sit in front. How many ways can the four sit on the car if it has 2 front seats and 2 back seats? So let us try to visualize this problem. So sabi, it has 2 seats daw in the front. So let's say this is the front seat and this is the back seat. Ayan. So in the driver's seat, so let's say this is the driver's seat. Only A and C know how to drive. So ang pwede lang umupo sa driver's seat is either A or C. Therefore, we can put this as 2. Then sa katabi niya, pwedeng umupo is A or C. Kasi pag si A yung nag-drive, pwedeng si C yung umupo sa tabi niya, or pag si C yung nag-drive, pwedeng si A naman yung tumabi sa kanya. Also, pwede rin si B. Pero si D, hindi pwede kasi sabi dito, D does not want to sit in front. So, may kaartehang taglay si letter D. So, ibig sabihin, A or C, so, one slot lang yun sa kanila, and si B, 1 din. So, therefore, dalawa yung pwede dito. Sa back seat naman, since dalawa na yung nakaupo sa front seat, so dito, dalawa pa yung pwede. And since 4 lang naman sila, so dito sa last seat, so isa na lang yung possible na mag-occupy. Therefore, our answer would be 2 times 2 times 1. Ay, 2 times 2 times 2 times 1. Sorry. So, that is equal to 8. Ayan. Next. So, permutation. When we say permutation, it is also called an arrangement number or order is a rearrangement of the elements of an ordered list S into a one-to-one correspondence with S itself. In combinatorics, permutations refer to the rearrangement of the elements in a given set. Here, we are concerned about the number of possible arrangement of a given set has. So when dealing with problems, take note of these keywords. So usually, problems having these keywords as for permutation. So yan, order, arrangement, rank, etc. And we also have permutation of n objects taken R at a time. Formula is NP equal to n factorial over n minus R quantity factorial. So it's actually in our calculator. So nasa ano siya, nasa times symbol. So if we will try, for example, if we have 12p5, so for example, if we have 12p5, instead of writing this as 12 factorial over 12 minus 5 factorial, so we can calculate this in our calculator. 12, then shift time symbol, the time symbol, okay, yung time symbol po. Nasa taas niyan si NPR, ayun siya. Okay, so if we will shift times, that's NPR, then we will have the answer. So 12P5, that's 95,040. Yan. Then for permutations of indistinguishable objects, we have a sub 1 plus a sub 2 plus a sub 3 plus so and so forth factorial all over a sub 1 factorial, a sub 2 factorial, a sub 3 factorial, and so on and so forth. For permutation with replacement or unlimited supply, that is simply n raised to k. Then for circular and ring permutations, so if arranged in a circle, we have n minus 1 factorial. If arranged in a bead or ring, that is n minus 1 factorial over 2. Okay, so in a press conference before the All-Star game, 8 All-Stars will be taking questions. 3 are Cubs, 3 are Red Sox, and 2 are Yankees. If teammates insist on sitting together, how many ways can the 8 All-Stars be seated in a row? Okay? So if we will try to visualize this, yan. So they are sitting in a row, and there are 8 seats, no? Ayan. So let us visualize them. We have 8 seats here. 4, 5, 6, 7, 8. Yan. So, we have 3 cabs. So, let's say this is for Cubs. This is for Red Sox. And this is for the Yankees. So, as you can see in this seat, we can have here 3, 2, and 1. This is 3, 2, and 1. And this is 2, 1. Or, this is 3 factorial. This is 3 factorial. And this is 2 factorial. So, this is the ways on how you can arrange the members of each team. But, as you can see, the team of Cubs, Red Sox, and Yankees can also be arranged in 3 factorial also, right? Because it can be Cubs, Red Sox, Yankees, or Red Sox muna, Cubs, tapos Yankees, or Yankees muna, Cubs, or Red Sox. Yan. So, we have 3 factorial also. So, let's just multiply them. So, we have 3 factorial multiplied by 3 factorial multiplied by 2 factorial multiplied by 3 factorial. And our answer is 432. So, ganun lang siya. Next, so in how many ways one can hang 10 different paintings on 5 empty spaces on the wall? So, this is just simply 10p5 and our answer would be 30,240. So, kapag ganyan yung problem, that's just simply permutation. Next, in how many ways can you arrange? So, arrangement again. 5 identical black balls, 3 identical green balls, and 4 identical white balls in a straight line. So, we're going to use the formula n factorial all over a factorial, b factorial, c factorial here. Since we have 3 ang tawag dito, objects like the black, green, and white balls. So, our n is 5 plus 3, 8 plus 4 is 12. So, 12 factorial all over 5 factorial, 3 factorial, 4 factorial. There. So, our answer would be 27,720. Okay, so for this problem, how many distinct permutations do the word engineering has? So kapag ganito yung problem natin, distinct permutation in a certain word, so all you have to do is to count the number of the letters. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11. Our n is 11. So may A factorial, B factorial, C factorial, and so on and so forth. This is 11 factorial. Letter E, how many E does engineering have? We have 3. How many N? We have 2. 2 lang ba? 3 pala. I'm so sorry. Yung mo magbilang. Ayan. That is 3. Ilan ng G? Dalawa. I, dalawa din. Ano pa natitira? 6, 7, 8, 9, 10. R. So, 1. And we're gonna put it here in the denominator. So, 3 factorial times 3 factorial times 2 factorial times 2 factorial times 1 factorial. And our answer would be 277,200. Okay, so there are 5 positions on a flagstaff and 4 different colors of flags, at least 5 flags of each color. How many different signals are possible by displaying 5 flags simultaneously? So, for this type of problem, we're going to use the permutation with replacement or unlimited supply, the n raised to k. Yung n natin is the different color of flags, the number of different colors of flags, which is 4. Then, our k here is the 5. So, 5 positions. Therefore, our answer is 1,024. Okay. Next, combinations. So, suppose we have a collection of n objects. A combination of these n objects taken R at a time, or an R combination is any subset of R elements. In other words, an R combination is any selection of R of the n objects where order does not count. So, order does not count, that is combination. Combinations of n objects taken are taken at a times, so that's NCR equal to n factorial over r factorial multiplied by n minus r factorial. So, in our calculator, nandun din si NCR. Katabi lang ni NPR kanina. So, yung NPR kasi nasa shift time. So, si NCR naman nasa shift divide sign. Okay? Ayan. So, how to differentiate permutation from combination? So, find keywords such as arrange, order, ranking, arrangement, or etc. So, these signify that the problem is about permutation. Keywords such as select, choose, in random, order is not important, denotes combination. So, analyze the problem. Problems involve dealing with groups of people oftentimes ask for combinations. Otherwise, the words like order is added. Okay? Order is important is added. Okay, so if there are 6 persons, in how many ways can they sit on a round table if 2 of them always want to be next to each other, while other 2 of them don't want to be next to one another? So we have here a round table. 1, 2, 3, 4, 5, 6, wherein there are 6 persons. And sabi, 2 of them always want to be next to each other. Magjowa. Ayan. So, this couple, let's say this is couple, we can just count them as 1 since ayaw naman nila maghiwalay. And use the formula n minus 1 factorial for the round table, no? So, n natin would be 5. 5 minus 1 factorial or 4 factorial. But since this couple can be interchanged, so pwede sila magpalit ng pwesto, that's another 2 factorial or times 2. So, times 2. And that is 48. And we have another condition. The other two of them don't want to be next to one another. Okay. So, paano gagawin natin? Kunin na lang muna natin yung ways na kung saan may couple and magkasama sila. Tung another two na don't want to be next to one another. Pag yung kabila yung kukunin natin. And then, isusubtract natin yun dito sa nakuha natin 48. Okay. So, kung meron pang dalawa, so let's say this one, we will count this as 1 also. So, this is another 2 factorial. So, we will have, count this as 1 na din. So, this will be 1, 2, 3, 4. So, 4 minus 1 factorial, and that is 3 factorial times this one and this one. So, times 2 factorial times 2 factorial, and that is 24. And we'll have to subtract this 2 para makuha natin yung pinakahinahanap nating ways na magsasatisfy dun sa dalawang condition. So, 48 minus 24, and that is 24. Ayan. Next, in how many ways can you arrange 3 different keys on a keychain? So, this is keychain, no? We have n minus 1 factorial all over 2. So, we will have 3 minus 1 factorial divided by 2, and that is equal to 1. So, isa lang pala. Then, my school's ECE club has 6 boys and 8 girls. I need to select a team to send to the IECEP competition. We want 6 people on the team. In how many ways can I select the team to have 4 girls and 2 boys? Now, we have here a key term, the selection. So, we will have to use combination. So, 6 boys and 8 girls. We want 6 people on the team. Okay, so 4 girls, so 4 will have to be taken from 8 girls, so 8 C4, and 2 boys from 6 boys, therefore this is 6 C2. Okay, so if we will type that in our calculator, that would be 8C4, then 6C2, and that is 1050. Next, in how many ways can you invite 1 or more of your friends into your birthday party? So in this case, let's just write this as 2 raised to n minus 1. So this is our formula. Then 2 raised to 5 minus 1. And our answer is 31. Next, we have a Venn diagram. Venn diagram calculations can be easily done using the principle of inclusion and exclusion. So the number of elements equal to the largest group minus the summation of the second largest group plus the summation of third largest group. Basic probability. So probability is the study of random or non-deterministic experiment. It is basically the ratio of the success over the desired outcome, called the event, and the total possible outcome, called the sample space. So mathematically, that is P is equal to event over sample space. Now let's apply the Venn diagram in this problem. A survey of 500 television viewers produced the following results. 285 watch football games, 195 watch hockey games, 115 watch basketball games, 45 watch football and basketball, 70 watch football and hockey, 50 watch hockey and basketball, and 50 do not watch any of these games. So question is, how many watch all of these 3 games? Now we're going to apply the Venn diagram. So let's draw 3 circles for the 3 games. Oh my god. So I'm so sorry for not so perfect circles. Ayan. And another one. Okay, so ang hinahanap natin is this X. The number of viewers that watch all the 3 games. Okay? Now, let's say this is for football, this is for hockey, and this is for basketball. Okay, so, sabi, 45 watch football and basketball. So, this is 45 minus x. Because this part is 45, but we have here x. So, this part only is 45 minus x. Now, for football and hockey, that is 70. Therefore, this one is 70 minus x. Okay? Then, this part, for basketball and hockey, we have 50 minus x. Okay? Now, to find this part, the only, football only, the hockey only, and the basketball only, so let's put this like, here's F only. So, we have 285. So, this represents all the population or sample for this circle. So, F only, that's 285 minus this one, 45 minus x plus 70 minus x, that is 115 minus x. 115 minus x. And that is equal to 170 plus x. So this is 170 plus x. For basketball only, that is 115 minus, this is 45 plus 50, that is 95 minus x. And this is 20 plus x. This is 20 plus x. For hockey only, ayan, hockey is 195 minus 70 plus 50, that's 120 minus x. That is 75 plus x. Okay. Now, to find the x, this is 75 plus x. So, of course, to find the x, let us add all these values. So, so you can see, this is just equal to 170 plus 70 plus 75 plus 50 plus 20 plus 45, okay, plus x, then equal to 450. Since the 50 do not watch any of these games and the total is 500, that's why it's equal to 450. Let's check. 170, 70, 75, 50, 20, 45. Okay. So, this is x is equal to 170, 240, 315, 365, 385. Oh my god, I'm stuck. 430, 430, right? So, 450 minus 430, that is 20. Okay? Ayan, 20. Next, a bag has 4 red marbles, 5 white marbles, and 6 blue marbles. 3 marbles are drawn from the bag without replacement. What is the probability that they are all the same color? So, concept of probability, that is E over S. So, probability, that is E over S. So our E here, 3 marbles are drawn. So it can be either from red marbles. So for C3, so 3 marbles will be selected from 4 red marbles. Or, so take note, or means plus. Okay, so 4C3 plus 5C3. So 3 marbles can be selected from 5 white marbles or can be selected from 6 blue marbles. So 6C3. Our sample, that is, of course, from 4 plus 5, 9 plus 6, that is 15. So that is 15C3. Therefore, our probability is P is equal to 4C3 plus 5C3 plus 6C3 all over 15C3. And that is 34 over 455. So next, Pikachu tries to solve a really hard problem once each day. He has 1/4 probability of solving it each day. What is the probability that he will solve it before his 6th try? So since he has the probability of 1/4 of solving it each day, so the probability of not solving it each day is equal to 3/4, right? So if we will solve it, we will have a probability that is equal to 1 minus 3/4, the probability of not solving it each day, and we'll raise it to what? So this before his 6th try, so that means 5. Okay, so Pikachu will try 5 times, okay, before he will finally get the answer on the problem is working on. Therefore, P is equal to 1 minus 3 over 4 raised to 5. And that is equal to 781 over 1024 or 0.763. Okay? Okay, so next we'll have probability operations. Probability of a sample, that's equal to 1. Then we have 0 less than or equal to probability that an event A can happen, less than or equal to 1, of course. So yung mga probability natin, lagi siyang less than or equal to 1. Then, P of E is to C, this is complement of an event. That's equal to 1 minus the probability of the event. Then we have P of A or B, or the probability that an event A or event B can happen. That's equal to the probability of A plus probability of B minus the probability that A and B can occur or can exist. Next, the probability of event B given event A. So that's equal to the probability of both A and B can occur at the same time over the probability of A. So in other words, event A has already happened, and this is also known as the conditional probability of B given A. Okay? So mutually exclusive events are events that cannot happen on the same time. Hence, for mutually exclusive events, we have P of A and B equal to 0. So two or more events are said to be dependent if the happening of one affects the probability of the other events. As for independent events, the probability of the other does not have any effect on the probability of the other events. If two or more events are said to be dependent, for them to happen at the same time, it is obtained by multiplying their individual probabilities. So kapag it is possible for them to happen at the same time, so that would be P or probability of A and B, and that would be the product of the probability of A and the probability of B. Okay, now let's apply this. So, Pikachu, Mudkip, and Cyndaquill have different chances of hitting the target. Pikachu can hit the target 3/4 of the time. Mudkip can hit the target 2/3 of the time. And Cyndaquill can hit the target 1/2 of the time. They all go for the target simultaneously. So, what is the probability that at least one of them will hit the target? Okay, so this is their chance, the probabilities or their chances of hitting the target. So let's have the probability that they will not hit the target. So for Pikachu, that is 1/4. For Mudkip, that is 1/3. And for Cyndaquil, that is 1/2. And since we're looking for the probability that at least one of them will hit the target, we will subtract this, the product of these probabilities to 1. Okay, because they will hit the target simultaneously, meaning at the same times. So this will be our formula. So P is equal to 1 minus 1/4 times 1/3 times 1/2, and that's equal to 23/24. Okay, next, what is the probability of drawing either an ace or a king in a single draw from a deck of 52 playing cards? So we have here the keyword or, and we know that or means plus. So drawing an ace from a single deck of 52, we have 4 over 52 because we have 4 ace cards and a deck of cards. Or a king. So we also have 4 king out of 52. So therefore, this is equal to 8 over 52 or 2 over 13. That's. Now, 2 people are chosen randomly from 4 married couples. So what is the probability that they are husband and wife? So probability E over S. So the probability that you will succeed in and choosing the 2 people as husband and wife is equal to 4 because we have 4 married couples. And all over the chances or the number of pairs that you could have, 4 married couples times 2, that is 8. And we have 2 people chosen randomly, so 2 pairs, so 8C2. Therefore, we have 4 over 8C2, and that's equal to 1 over 7. A point is selected at random inside a circle, so find the probability that the point is closer to the center than to its circumference. Okay? Ayan. So let S denote the set of points inside the circle with radius R, and let A, so this part, denote the set of points inside the concentric circle with radius R, 1/2 R, this one. Thus, A consists precisely of those points of S which are closer to the center than to its circumference. So our probability, this probability, that's the probability of the area, that's equal to pi of R over 2 squared over pi R squared. Therefore, a pi will be cancelled and we'll be having R squared over 4, or that's equal to 1/4. Ayan. Okay, so 2 red books and 4 blue books are placed at random on a shelf. What is the probability that the blue books will be together? So we have given 4 blue books. So sabihin natin na we have here 2, 3, 4, 5, 6 books. And the blue books will be together. So let's say these are the blue books. And these 2 are the red books. So, yung 4 books natin, they can be interchanged as long as they are together. So, this will be 4 factorial. And this will be counted as 1, right? if we will rearrange blue together with this red. So, this blue, pwede siya nasa gitna ng dalawang red, itong apat na to, or pwede rin siyang nandun sa kabila. So, rearranging them means 3 factorial because they are counted as 1, then 2, and then 3. So, 3 factorial. Therefore, our probability that is equal to E over S, that is 3 factorial multiplied by 4 factorial all over our sample. We have 2 red books and 4 blue books. Therefore, this is 6 factorial, and that's equal to 0.6.